Hi, I'm Mr. Kangas, and today we're going to be taking a look at Chapter 5, Section 4, Dividing Rational Numbers. And today we're going to be taking a look at two things. We're going to be looking at how to divide fractions, which I briefly went over in one of my other videos, which is why dividing fractions works. And we're also going to be taking a look at how to divide an algebraic fraction, which isn't drastically different. But if you want to know why, I'm only going to show you the shortcut for how to divide fractions today. If you want to know why that shortcut works, please watch the other video of Chapter 5, Section 4 called Why Dividing Fractions Works. And that will give you a pretty detailed explanation as to why it is we can flip and multiply, which is the shortcut for dividing fractions. Now, if you have two fractions that are being divided, normally what you would have to do is, just like with multiplication, you can go straight across and divide them. And so 3 divided by 6 would get you 0.5, and then 4 divided by 7 would get you another decimal on the bottom, or the denominator. And we typically don't like having decimals in our fractions, even though fractions are division problems and you can divide decimals. We just don't like having them there, so we like to avoid them if possible. So this way can get very messy. It can take a long time to solve a problem, because you're going to have to do a couple of division problems out over on the side, which will take up more paper and more room. Most of us would agree that multiplying is easier for us than division. So if we could find some way to multiply these numbers together, that would be preferable. And there is a way to do that. It's called flip and multiply. You flip the number on the right, you change division to multiplication, and this will get you the same answer as the original problem up here. So for example, after I flip and multiply, I can now multiply straight across, or before I do that, since I have a multiplication problem now, okay, I can cross cancel or diagonal reduce. I could not cross cancel up here because I'm dividing. Cross-canceling only works when you're multiplying fractions. So I could actually cross-cancel the 3 and the 6, because 3 goes into both 6 and 3. Like that. So in other words, I divided the 3 by 3 and I divided the 6 by 3. I found a number that went into both 3 and 6 evenly. So now I can do my multiplication straight across. 1 times 7 is 7. 4 times 2 is 8. And so my answer is 7/8. So to divide fractions, you flip the number on the right like I did here. I took the 6/7, changed it to a 7/6. Then you change division to multiplication. The number on the left stays the same. At this point, I had an option. I could have just gone straight across and multiplied and then reduced my answer after, or I had the opportunity to look for the ability to cross-cancel or reduce my fractions before I solved, which I did. I cross-canceled the 3 and the 6, or diagonal reduced. So another example real quick of that. Let's do 4 over 2 divided by 6 over 4. So again, I'm going to flip the number on the right, change division to multiplication, keep the number on the left the same, and at this point I can either cross cancel, I can reduce, whatever, or I can just multiply straight across. I'm actually going to do a little bit of cross canceling. I can cross cancel my 4 and my 6, because I know that 2 goes into 4 and it goes into 6. So 2 goes into 4 twice, 2 goes into 6 3 times. 2 also goes into the other set of diagonal numbers. So 2 goes into 4 twice, 2 goes into 2 once. At this point, I can multiply. 2 times 2 is 4, 1 times 3 is 3. And just to show you that flipping and multiplying does work, this is like a easier, not necessarily proof, but an easier way to understand that flipping and multiplying works. In the video on why dividing fractions works, I go into a lot of detail as to why, and I go into a much more detailed explanation, but just a quick example to show you that, yeah, this does work. Let's take a problem that we're all probably used to, which is 8 divided by 4. Should get us an answer of 2. Now, when you have whole numbers, if you want to make them into a fraction, you just put it over 1. This still gets me an answer of 2. So if I flip and multiply, I end up here. So 8 times 1 is 8. 1 times 4 is 4. And so I get an answer of 8/4, which is equal to 2, because 8 divided by 4 is 2. Or if you wanted to reduce the fraction, you would reduce 8 by 4 and get 2, reduce the 4 by 4 and get 1. And so either way, you're going to get the same answer. That's like kind of like a quick mini proof. It's not necessarily the technical proof, but for most people, that's enough for them to say, oh, okay, this does work. Because flipping and multiplying is definitely a little weird when you first hear about it. But here I've shown you that, I've shown you an example that you're used to, so you can see that yes, it does work. In the video on why dividing fractions work, I get into a detailed explanation as to why flipping and multiplying does what it does. Why does it work? It's actually not too complicated to understand, but it is a pretty lengthy video. So be prepared for about a 20-minute video. And that is all I've got on dividing fractions. In the next video, I'll be talking about dividing algebraic fractions, which isn't too much different. Just requires some of the prior knowledge you learned in previous chapters on multiplying variables. So tune in for that video.